Welcome to the second FoxATM interview. This episode will be all about the space-based ADS-B services provided by Aireon, and will specifically look at the safety aspects of it, both in terms of techniques, but also processes and certification. My guest is Cyriel Kronenburg, who is VP of Aviation at Aireon, and he also invited Sinéad McCloskey, who is Senior Director for Safety and Service Operation, as well as Vincent Capezzuto, who is CTO and VP of Engineering at Aireon. Before diving deep in the subject, a first round of introduction. Please, Cyriel, if you can start.
Yeah, thank you, Vincent. Cyriel Kronenburg, the Vice President of Aviation Services for Aireon. I've been with the company since the start and responsible for all the commercial data services for the company.
Okay, with you today, you invited Vincent Capezzuto, who is CTO and VP of Engineering, if I'm correct?
That's correct.
And we also have Sinéad McCloskey, sorry if I mispronounced your name, who is in charge of safety at Aireon. Is that correct?
Yes, and don't worry, my name is frequently mispronounced. It's Sinéad, or Sinead, I should say. Yes, I'm in charge of the safety aspects, but I've recently taken over the operational service side of things as well.
Thank you for the clarification. I guess Aireon is a well-known name in the ATM industry by now, but I'd like to have Cyriel introduce the company rapidly for those who probably missed some aspects or never ever came across Aireon before.
Yep, thank you. Yeah, so Aireon was formed back in 2012 as an idea. We are the first of its kind air traffic surveillance company from space. So we are operating a constellation of space-based receivers that are riding on the Iridium constellation. They were launched in the latter half of the 2015 till 2019, but operational in 2019. Currently providing air traffic surveillance from space through ADS-B receivers to about 16 operational air navigation service providers, which spans well over 30 countries in the world. We're doing that as a service, so Aireon does all the background work. We're providing we're receiving the data from the satellites. We're doing the processing and providing the data to the air traffic control company, where it gets entered into the tracker or into the automation platform. So we're doing that fully as a service. We're a safety certified organization, safety certified through EASA, certified as an air navigation service provider. So we're really an extension of an air navigation service provider for the surveillance part of CNS.
Great, thank you for the introduction. Let's jump directly in the topic. Your air navigation service provider customers obviously rely heavily on the accuracy and continuity of your service, especially in Oceanic area where Aireon data is the only surveillance source which is available. How did Aireon prepare for potential incidents, let's say worst case, total outage of data that could affect this user?
So let me initially take that from a ConOps perspective and the customer perspective, and I'll hand it over to Vinny to talk a little bit about the design side of Aireon. We are, as I mentioned, an extension of an air navigation service provider, but in fact, we are just a layer of surveillance. So I think with most of our customers, it starts with we are not the only form of surveillance, except when there is no alternative possibility, for instance, over the oceans. But in most of our airspaces where we have terrestrial customers, we are a layer of surveillance, just like radar or ground-based ADS-B or multilateral Aviation are. So in most of those cases, the concept of operations dictates that the tracker picks up the strongest signal or the priority signal, in which case we could be the primary source of surveillance, or we could be the secondary or even the tertiary source of surveillance. And if anything would happen on our side, that would eliminate our service. The other form of surveillance would pick up, just like it would be with multiple radars or multiple layers of ADS-B and overlapping stations. On the oceanic environment, this obviously is slightly different, but it is not any different than having a single source of surveillance on the ground, for instance, a single radar covering a piece of airspace or a single layer of ADS-B. The controllers have to abide by different separation standards in that case. So in the Oceanic environment, the ICAO SASP recently introduced new separation standards, which are going through the final approvals right now, expected to be approved by November for global use. And they're currently in use in the North Atlantic. These are 14 nautical mile separation standards and 17 in some more dense routes, where the controller effectively has 191 seconds if the primary source surveillance, which would be space-based ADS-B, but it could also be ground-based ADS-B. But if that would fail, the controller effectively has 191 seconds until they have to go back to a secondary form of separation or alternative means of separation, which traditionally would be going back to ADS-C. So ADS-C is still mandated in the North Atlantic, and it will remain mandated in the North Atlantic. So that will be the fallback for a controller. And of course, worst case, they would have to go back to a full procedural separation. But that is really in the worst case scenario that our data service would not keep flowing. But obviously, our system is designed to not get to that point. So I'll hand it over to Vinny. You can talk a little bit to that.
Sure. Let me extend on that. I think what's important when you're considering how to design a system that addresses the particular issue you have raised, Vincent. We start with the concept of looking at redundancy and resiliency. So starting, think of this from a set of subsystems. There's the component of it that's in space. That's the receiver that receives the 1090 megahertz signal from the aircraft. There's also the component of it once it's grounded on the Earth, where we do command and control of those components. And then and there's a subsystem that does that element, and it also passes the data onto our data processing section or subsystem, which finally delivers the data to the customer. So if you peel apart each one of those elements, the hosted payload, the component in space, is redundant in power supply and in receiver. It also is redundant in a very large way with the footprint of each one of the satellites. So I think Cyriel mentioned there's 66 operational satellites in space. We also have 7 spares in space. And each one of them is capable of a footprint that's larger than the United States. It's larger than 3,000 nautical miles from one end to the other. And so they're all overlapping. Those 66 satellites are not static. They're moving in a consistent basis around these polar orbits. And they're with the overlap, you essentially, for a large percentage of the Earth, you are always under dual or triple or quadruple coverage from each one of those receivers. The hardest place is on the equator, and even there we still have all the fringes of the one large footprint overlapping with other ones. And so those satellites are constantly moving. They rotate around the Earth 100 minutes. So they leave, if they're over Florida, they'll be over Florida 100 minutes later. And they're constantly rotating around the Earth. And so once we've established that, the redundancy, the resiliency of the detection of the signal from space, the signal is brought down in multiple locations or grounding teleport networks. So we can use the infrastructure or the mesh network of Iridium as kind of our communications and space provider, and essentially we route the data to multiple grounding locations in the world, in the Northern Hemisphere, and then from there, so you have more resiliency and redundancy there, and then from there it finally gets routed to our prime location where we start the processing of the data. So the command and control is performed in 2 locations in the United States, one in Virginia, one's in Arizona as a backup. And then that data, it gets passed through these locations where we have operators that are actually commanding the payload, so we can upgrade the payload to new future builds. So that's another way of future-proofing the service and making sure that we can upgrade it to new designs for avionics. And then, so those operators are constantly monitoring the space element of it, but then the system, that subsystem, also passes it over to the data processing subsystem, which is located also in Virginia in another location. And also, we have one's a data center, like an AT&T data center. So it's a highly secure area. And then the other one's about 20 miles away in a factory environment where it has the resiliency of backup power and UPSs for uninterruptible power supplies. And personnel are located there as well. So we have multiple network operations centers that manage the subsystems and the networks between them until ultimately we take the data processing and ship it to the customer. In all these cases, we're using multiple contractors for the telco provisioning, and that's another form of resiliency and redundancy. So we make sure that we're using different telco providers and the local providers at wherever the location of the customer is. And so that's a component of like the availability calculation. But another layer on top of this is the security posture. So 1090 megahertz is broadcasted in the clear. We receive it at the satellite level. First thing we do is encrypt it. It stays encrypted as it goes through the Iridium infrastructure, including the command and control subsystem. And even there, the data is just passed through, still encrypted. No one can access it. And since it's being grounded in multiple locations, all the packets are kind of being reassembled at that one data processing location, whether it's at the data center or in Virginia as the backup in the factory setting. So in those two locations, we finally unencrypt it. We compile all the data that we've collected from all the observing satellites and create the actual aircraft target reports. And then we geographically filter it, re-encrypt it, and send it to the customer's location. And then it gets unencrypted at the customer's location. So it's a pretty closed system. It's not open internet type connections. These are all virtual, these are private lines. These are insured with encryption. And so we put multiple layers of security to ensure that people cannot access the data and do any harm to it. And our number two rules in the safety case, right? Don't drop any data, don't corrupt the data.
Okay, great answer. Thanks for all the details. Just maybe a quick yes/no answers on the next ones. If I got you correctly, there is no single satellite failure that could cause gap in the data because the coverage itself is redundant because you have enough satellites up there.
There at the equator, there could be, if one satellite went out at the equator, there could be a 2 to 3 minute gap in surveillance.
Okay. What kind of procedure do you have in place to inform users in such cases, and how quick can you cover that?
Yep. And so there's a technical answer, but I think more importantly, Sinead could tell you how we interact with the customer. And we could even cite an recent example of how we were proactive in that communications and essentially ensured that they were able to do what they needed to do. And we were able to bring the service back online. So let's use that.
Yeah, so from the service perspective, we're constantly updating the customers themselves with any outages that we have. So we break those first of all into whether it's a planned outage or an unplanned outage. Planned outages are, warned in advance. We have a maintenance calendar. It's there for all the customers to see. We ensure that they've all been notified correctly through various procedures, meetings, in the run up to that with regards to specific releases, software releases maybe, and the service desk technicians then manage all of those calls at various intervals in the run up to a plant maintenance. Where we would have or experience what we call an unplanned outage, again, we treat that straight away as an incident. So our service desk technicians respond to that. Same again, they notify the immediate customers that are affected. If it's every customer, then obviously we notify all the customers together. But if it's a particular customer with regards to, for example, a particular satellite or a particular service volume, then we concentrate on notifying the affected customer first of all. But we have tools within the system as well, as Vinny mentioned earlier, where we have the satellites are constantly moving. So an unplanned outage for one customer we have the ability then that becomes a planned outage for another, because we have the ability to predict where it's going to hit next, warn the next customer. We can plot it on the map basically, and make those calls in order to say, we have an unplanned outage. We have one satellite affected. We're predicting it's going to hit your area in 30 minutes time. And as that then progresses, obviously that time period for the the ongoing customers or for the next affected customers gets larger and larger. So that's one of the tools that we have available, but it's all managed from the service desk. We have notification procedures all set up through various mechanisms. And as I say, when it's planned, it's put in the diary weeks in advance. We negotiate time slots. We make sure, because we have the understanding of how an air traffic service provider operates as well, and their requirement to notify and change procedures and make sure that it's all managed effectively.
Sinead, just to kind of add to the one example, we started noticing some issues with our service, and it wasn't really impacting any customers, but the minute we detected that, we communicated to all the customers that there was a potential. And then from there, they were able to decide not to apply reduced separations for the push that was coming up. And that way they kind of abated having an issue prior to it. So Vincent, it's always situational. It depends on the actual type of outage. We have things that are degraded service, meaning one of those telco lines went down, but the other one's still up. So it's degraded, and we indicate that to the customer so they're aware we're running on one line when typically we would have two as a backup. And it's those kinds of scenarios. And I think the great thing that we've done over the last year since we've been operational is to establish the protocol for that communication and to speak in the vocabulary of the ANSP, because it was super important to be able to clearly explain when the service was back up what we meant by that, and that they could start using it again. And so those were good learning experiences for all of us. And obviously our customers desire the service and are interested in ensuring that we are tuned up and able to provide and speak coherently in their language.
You said a lot on how redundancy is built in the system and there is no single point of failure and you have double chains, double channels, but it's still a long chain. I mean, from the payload on the satellite to the end user, you probably have a lot of steps. Where do you see the biggest hazards and how do you mitigate them the best?
So great question. And, interestingly enough, probably our biggest challenge is telco provisioning from the United States to any one of those customers. And again, it's situational. Go to Europe and you can get a secure telco line pretty easily. Go to Africa and it's a little different, right? So you are challenged with the, getting the redundancy, and you're still almost forced to use the local provider once you get on the island. So you're always coming into the same entry point. So what we're looking at is providing resiliency through various means. In other words, you could use a fiber for one of the lines and an RF link for the other. And so we're starting to explore all these capabilities and permutations. A second is a great example of having a submarine cable that was recently in January, had an issue, and we had our backup line and we were still running properly, but we've looked at this now and thought about it and said, it would probably be beneficial for us to put a third line in just to be prepared and not to use it as a submarine cable. Maybe, so we're looking at an Intelsat and considering a satellite-based comm link into the various ANSP locations. So it's those kinds of things that we've met the requirement, we deployed the system, but now we're learning and saying, why don't we just put in the extra padding or security, just the extra insurance of making sure we have a tertiary line. We're doing the same thing in India right now in deployment. Taking
a step aside from really technical stuff and go more on safety, you have been certified under EASA rules as an ANSP for technical services. How was that safety assessment performed, given that the safety process here will definitely depend on how your customers are using the data? I mean, you don't want the same safety levels if Aireon's data is the only provider, or if it's one more layer in a multi-source environment.
So we took the decision long before I joined Aireon. The decision was taken that we would embark on the certification journey with EASA in recognition, if you like, that many of our customers, or most of our customers and investors at the time, were European based. So the journey started with the certification of the system itself, but it goes way beyond that. So we're certified under an ATM ANS certification. So it's recognized that we are a surveillance provider, but we are certified as not only as a provider of surveillance, it's the entire organization that's certified, because we are providing that surveillance as a service. Now, it's not, we're not providing a piece of equipment, we're not providing a data feed, we're providing the entire service. So it was there were many elements to it for most of the European ANSPs and most of the, under ICAO as well. There are specific requirements with regards to assuring the system, to go all the way back to derivation of assurance levels with regards to software, with the failure modes and effects, identifying all of the hazards, and actually making sure that we had mapped those to the particular safety requirements that we'd identified. And the step on from that then is, once the system is performing and running, then how do we actually operate the service? So the certification goes way beyond just the system. It takes into account our management practices, management system, our training and competency, how we recruit, how we train, how we train service desk technicians. Many of our personnel are designated as ATSEP, the Air Traffic Safety Electronics personnel. So all of the EU regulations that apply to any other air traffic service provider also applied to us as well. So we had to work very, very closely with EASA. We've been quite lucky in that the team that was appointed at the very beginning to start the initial round of certification audits have been with us on the journey. It's been a learning opportunity, I'd say, for both sides, because one, it's the first time this type of service has ever been certified by any regulator. And with any type of service like that, when we talk about whether, a greenfield service or one that previously didn't exist, you tend to find the regulation doesn't quite fit the mold either. So there's a lot of negotiating and a lot of work that needs to take place with your team of regulators in agreeing what is appropriate and what meets the compliance of a particular rule. So that's been a lot of the work that was done. They embarked on a series of 4 certification audits in the run up to the initial certification. And we finally got that certification granted last May, and that was the full EASA certification for the oceanic environment. That was then, it grew and evolved then when we brought the completed further testing and rounds of testing and evolved the system further so that it is now certified for both the oceanic and the en route environment, and that took place last December. So the system is constantly evolving, and as we constantly improve, then obviously the certification changes with that as to what we're actually, the certification calls out quite specifically the performance of the system and where it performs to that level as well. So it's been quite a lot of work gone into that, and we're now post-certification where it's the ongoing certification, and we're still obviously carrying out our ongoing certification audits with EASA with mostly the same team, and same again, we've got one coming up in June, for example, and another one later in the year. So
okay, so if I get you correctly, the certification was done by EASA, by a team of EASA working with you, and you have a certificate issued by EASA.
Correct.
Which leads me to the next question, because safety in Europe is still a puzzle with EASA having oversight, but each country still has a national regulator. Mm-hmm. So how is that transfer from something that has been certified by EASA working with local regulators in Europe? And maybe if you can also comment, how is that working outside of Europe where EASA is not directly responsible or relevant?
Right. Yes, and a very good question. As a lot of people are aware that you have their own country or state regulator. They even know that the EASA is the governing body across Europe. So we took the view very early on that we had to bound the safety case, if you like. So we took the decision and made it very clear that we were taking the safety case deals with the receiver in receiving the data from the aircraft up to the point, what we call the service delivery point. So that's, we assure the data and the integrity of the data from the point that it's captured, if you like, right down to the service delivery point. Service delivery point onwards, and the implementation of the data into an ATM platform becomes the responsibility of that particular ANSP. We did that for several reasons. Basically, because many regulators are different around the world. And also every ATM platform is not necessarily, you know, it can be different. We have different providers, different manufacturers and suppliers of ATM systems, and also variations between the service provider as to how they might want to use the data. So we might have, for example, the Oceanic environment, and they may only want to use it in the Oceanic environment. And then we may have other organizations with many countries within it. ASECNA being a good example, where it was like 17 different countries with their own regulators under the ASECNA umbrella. But the view that we've taken is, here is the Aireon safety case. This assures the performance of our data to this level, to these points. Beyond that point, we advise that every ANSP then conducts their own or develops their own internal safety case, as they would have to do for any other form of surveillance or anything else that they would be introducing to their own system. It is normally expected that they would then develop their own internal safety case that deals with how it's implemented, the engineering aspects of it, right down to then how their air traffic controllers intend to use it, and procedures, etc. Now, in the development of our safety case, we consulted with those ANSP customers. We called on the expertise and air traffic controllers of our customers and investors to make sure that what we were taking account of in our own safety case, the assumptions that were made around how data would be used, etc., that they could validate all of those. So it was very much a joint effort in the early days to brainstorm and make sure we'd identified hazards, that everyone agreed with the assumptions that we were making, and then that's the understanding that then all an ANSP needs to do is take the data from the SDP service delivery point and make sure that they have captured all of those aspects in their own safety case for their own regulator. So,
if I can just add to that, just in summary, because you asked a question, Vincent, if other ANSPs would accept sort of the EASA safety case, or if it would be of value to them. And the experience to date with the other customers that have gone operational, such as Curaçao, they have, even though EASA isn't the regulator to them, they had an independent group look at the EASA safety case and effectively said, because of the fact that Aireon's safety case has an EASA certification behind it, we don't have to look at this anymore. And they only focused on their own internal safety case, effectively from the SDP onwards into the ConOps. And we see increasingly that customers who recently signed up or who are currently looking at our system have used the EASA certification as a differentiator in their RFP proposals, and actually made it a very critical element that we had to demonstrate that we had a safety certification before we could even submit a proposal for instance, a layer of surveillance where we were competing with ground-based ADSB or with radar. So it's been very helpful for us in various parts of the world.
That's a good point, Cyriel, and ASECNA again was another good example of that, where they weren't entirely sure how they could address or what was the best way forward to address the development of their own safety cases. Our team with EASA have been very, very cooperative and very helpful, and invite contact from other regulators to collaborate on exactly what EASA did and the approach that they took. As well as that, we have also called on, for example, NAV Canada, another one of our investors that does not fall under the EASA umbrella. ASECNA were invited to also go and collaborate with NAV Canada. So they went, they visited, asked what questions they wanted to, and then made a decision on what was the best approach for them. So it's very much a collaborative effort, and what is nice about this as well is that certainly from our investors and our existing customers, everyone is prepared to share that knowledge and share that experience. So we can always call on support, as well as our own sort of internal safety resource. We've also said that, you know, we can give guidance on best practice or best ways to approach. So I'll let Benny go back. Thanks.
I was just going to add a little bit to it, because there's we essentially through collaboration, we've lowered the technical barrier as well, right? So we've worked with Thales, we've worked with Leidos. So we have relationships with them, and we established the ability to do the interconnection to their automation platform. So it's not such a big gap once you arrive. And to talk about, well, what else can you do? Well, there's standardized interface controls, right? Eurocontrol has the asterisk category that defines what the data format looks like going into an automation platform. And so we adhere to those standards. And what was nice about, you know, it was difficult enough to design a system, but you design the system around the existing standards. And ADSB is a pretty mature technology in that regard. EuroK has ED129B that defines what the ground infrastructure is supposed to be designed around. So we've basically have used these as our guideposts in the design of the service. And so we didn't have to reinvent everything, right? We're working within the existing construct that any other ground-based ADSB would be using regarding what should the system perform at, and then how do you interface to the automation systems. And we make sure that we actively engage at EuroK, at RTCA, at ICAO, at CANSO. And so we make sure that we're engaged with the community, both on the technical end and on the operational end.
I think it's a really great message to the community here that when you go to Aireon, you just not get data, but you get support in terms of safety, in terms of integration, what I hear now, and also in terms of certification and everything. Because it's a big step for an ANSP, I guess, to jump into that. My last question is the obvious question today. Are you in some way affected by the COVID-19 crisis in your operation and in your development of future projects?
Like everyone else around the world, yes, we are affected. It would be incorrect to say that that's not the case. From this service operations perspective, that's been the focus. So the focus has been prioritize that the service is stable and is still running, that despite the drop in traffic levels around the world, air traffic control providers are still operating, aircraft are still flying. We don't provide a service based on the number of aircraft, if you like. We're still providing services globally to our customers. So that's been our focus. We're taking all of the guidance that's out there, obviously, to make sure that we protect that service delivery aspect of it. We, like everyone else, the rest of the organization is working from home, and that provides its own challenges, if you like. But our focus has been on the customer service desk, the customer service operation, and making sure that they can continue to operate and make sure that the service is guaranteed as far as we can. Bar an outbreak, actually within our own team or within our own organization in the room, in which case we do have other contingency arrangements set up. We've worked with our various partners at various locations to see exactly what we can do, where we can do, where we can do it from, etc. With ad hoc rosters and making sure there's someone always on point for that. And obviously that we designated, like everyone else, designated individuals within the team to say whether or not they were what we call primary operations, secondary operations. And secondary operations would be if we did develop any sort of a problem that requires troubleshooting or any aspect, any sort of more in-depth engineering aspects beyond the service desk, that we also have those available on an on-call basis to come in. And if they can't access remotely, then they can come in and work on the system as well. So we've taken all of the same steps, the same as, probably not to the same extent as an air traffic service provider, but not far off. Yeah.
Yeah, I was going to add to that, Vincent. I think from a business perspective, this time offers a lot of opportunities as well. I believe. I mean, first of all, we started the engagement with CANSO to share our data with the broader ATM community to try and sort of advance the data-driven approach to the recovery of this on a global scale. But beyond that, I mean, we're getting a lot of outreach from various ANSPs right now who either are in the process of entering into large-scale projects, which they either have to defer or the business case changed because the traffic forecast is not as dire as it was before, where the business case for having something as a service really changes the paradigm right now. But I think you will also start seeing, and this morning on a CANSO call that you might have been on with the Asia Pacific region, there were a few ANSPs that mentioned that they will start rethinking sort of how they operate. I mean, some airports where there was a business case to have a tower, there was a business case to have a radar because of the levels of traffic. If those levels are not coming back anytime soon, that business case might change, and they might opt to retire a radar, or they might opt to go to a remote tower, in which case our technology could be a very cost-effective alternative. And that's what we're currently seeing. We're getting a lot of outreach in this time and day, both on the CDM type, the ATFM side of the business, and sort of reaching out for the recovery in data sharing. But on the other hand, this is an alternative to multiple layers of hardware on the ground where you have a lot of staff maintaining that. I think it's becoming more interesting now for ANSPs to look in that direction as a potential fallback for contingency. So I think that's for us an opportunity. And we're also seeing a lot of outreach on the airport side where if traffic is less busy, does it justify having a radar at the airport for ground movement and not so much for separation, but our data reaches all the way to the ground in most parts of the world. So could this be an alternative capability there? So we see a lot of positives, but of course, I mean, our thoughts are mostly with our customers. We're having a very hard time, including the airline customers that we have. And so we've helped a lot of our airline customers with providing some relief and on the data provision through our partners and direct, and we'll continue doing that while the situation unfolds.
Great insights on the next steps and the situation. Thank you for that. Is there any final words you would like to add before we close the interview?
I mean, we're looking forward to getting back on track, I think, but so does the entire industry.
Great. So thank you to all three of you for taking the time, even in this specific periods, and having the opportunity to review even from homes. I really appreciate that, and there are a lot of positive messages in what you said, and I thank you for that.
Absolutely.